This Explain Everything is about electrochemical cells. We're going to look at galvanic, voltaic cells, the spontaneous, but look at what happens when we have a gaseous electrode. First of all, let's create two half reactions that are connected by a salt bridge. And on this right hand side, I'm going to put a sort of way we describe a gaseous electrode. And we're going to use an example of the hydrogen acid half equation or reaction, which is the standard hydrogen cell. You'll see on your reactivity series, everything is related to this. And this is, of course, at 298 Kelvin and 1 molar solution. So what we have in here is a solution of hydrogen ions, and that, of course, can be hydrochloric acid. The anion is so important as long as it doesn't precipitate at any point. We also then have an electrode that is where the electricity is conducting, and in the standard half equation using hydrogen, it's an inert one like carbon or platinum. And let's say our other half cell has a metal electrode, and we'll connect them up as usual. So we can see that the only difference here is the nature of the electrode in the right-hand cell. Okay, let's take a metal that's more active than hydrogen, and that, if we look on the reactivity series, there's a lot of them. Let's just choose zinc, for example. Put zinc there, and of course then put zinc in a solution of its own ions. What will happen? Well, let's put our zinc 2+ here. Zinc is more active than hydrogen, so zinc will choose to oxidize, and hydrogen will prefer to reduce. So while this is usually connected to a hydrogen supply here, what we have is that the hydrogen is going to be produced in this reaction. Let's mark the end of our electrode here too. So we know that zinc is going to oxidize, and that oxidation occurs at the anode, and then hydrogen is going to reduce, which occurs at the cathode. We know that the anode is the source of the electrons flowing in this direction here, so we say that the anode is the negative terminal, and it's coming into the positive terminal, the cathode here. And hydrogen in this case, of course, is going to be H+ is going to be making hydrogen, so that's going to be bubbling out at the cathode. All right. We still have the same as before, where the negative charge moves in the clockwise direction, which means that any negative anion in solution is moving in that direction too, in the cathode cell towards the salt bridge, and whatever the anion is in this cell towards the electrode. Now, in terms of electrode disintegration, zinc is still breaking down, so this anode here will disintegrate, but the cathode is not going to build up with anything because the hydrogen gas is escaping. Now, your task is to create and draw what would happen in a half cell if we had a metal that's less reactive than hydrogen, let's say copper, in a solution of its own ions, and we still had the hydrogen half cell. Attach this to OneNote on the homework and reference it to this part here of Explain Everything, electrochemical cells.